So we'll do this one two ways, tech active and tech free, just so you have the different strategies depending on which test it is in. And clearly the first issue is getting a diagram from the words. So let's just say the plane's coming this way. So that will be the altitude, and it initially comes in at an angle of elevation of 30 degrees. So that means that's 30. And then 1 minute later, it's at 45 degrees, and that's 1 minute. If it's 900 kilometers per hour, divide it by 60, and I'm pretty sure we get, this is 15 kilometers. So we want to just convert that speed to a distance. Okay, let's fill in stuff that isn't actually given. So that would be 135, which means that's 15. And what I'm looking at really is this triangle here and going, if I know that side there, I'm home and hosed, and I'm going to find that side by looking at the red triangle. So let's just go, that's X. So because I've got an angle, and a side opposite, that's the sine rule. So I'm going to go 15 kilometers over sine 15 as the angle. Sorry about that, there's 15s everywhere. That will be X over sine 30. So my X will be, using my handy dandy calculator, 28.98. So now all of a sudden I'm looking at that X. I guess I'm going to make a mess here. There's my right angle triangle. I've got my angle, my hypotenuse. All I'm going to do is go, well, that's going to be sine, isn't it? Sine 45 equals H on 28.98, and calculator H equals 20.49, which is hopefully what you got. So with the calculator, it's just using the sine and cosine rule, looking at that big non-right angle triangle first, and away you go. Tech free though, we can't really do that because we can't work with this sine 15. So without a calculator, that strategy is just not going to work. So let's get a diagram again. So that's H. Well, that was 15, 30, 45, and right angle. So I'm thinking I want the minute it doesn't have a calculator, I'm probably just going to, I can't look at this non-right angle triangle because that's a 15 degrees, and then I don't know, I can't do that without a calculator. So I'm really stuck with right angle triangles because that's got my 30 and my 45, which I'm okay with. So let's get a green triangle. So from the green triangle, what's common in both of those triangles is this side here. And what we don't know about that side is that length there. We know that's 15, and we don't know that, so we'll label that X. Okay. I'm going to use my green pen because I'm going to look at that green triangle and go tan 45 equals H on X. Now I'm going to look at my red triangle and go tan 30 equals H on X plus 15. Pretty much now I've got two equations, two unknowns, that diagram can just disappear. I guess I can just go back to my blue. Tan 45. Are you okay that tan 45 is just 1? If you're not, come see me. So that just moves to there, and from that I can say x equals h. Tan 30, let's see what tan 30 is. So triangle, my 30-degree triangle. Tan 30 is O on h, so tan 30 is 1 on root 3. Let's get rid of that triangle. Equals h on x plus 15. So I have got 2 equations and 2 unknowns, and I don't know whether you see it. I'm wanting to find h, so I'm going to put that x in there and get 1 on root 3 equals h on h plus 15. So that's simultaneous equations by substitution. 2 equations, 2 unknowns, substitute in, and away we go. I'm going to multiply by that bracket under there and get h plus 15. I'm going to get rid of that root 3 up to the other side. Get the h's to one side. I want h equals. So I only want one h, so let's factor it out. And all of a sudden h will be 15 on root 3 minus 1. There we go. Laughing, that was so much fun. Good stuff.